This is Softwareable Bytes. Hello and welcome to another episode of Softwareable Bytes. This is the show where I read to you articles and blog posts on subjects like software and cloud engineering and architecture, site reliability engineering, DevOps, and everything in between. If you are looking for software and cloud development services and training, check out softwareable.com. We help customers in their software and cloud journey, whether it's taking software from ideas to complete solutions, migrating existing systems to the cloud, or mentoring and training individuals and teams. We make it work for your needs. Go to softwareable.com, that's software without the E, IBLE.com to learn more. Today, I have an article titled How to Drive Ownership in Microservices by cortex.io. How to Drive Ownership in Microservices by cortex.io. Microservices has become the de facto architecture standard amongst modern software development teams. Netflix is widely known for its microservices architecture, and technologies like Microsoft Azure and Confluent place microservices at the center of their product's value add. For teams who haven't adopted it, there is a wealth of information available on why transitioning from a monolith application to one defined by independently deployable services is critical to building a reliable product at scale. As much as it's doted upon in the industry, however, adopting microservices in and of itself isn't quite enough to claim success. To ensure that your application architecture truly enforces a separation of concerns and is resilient to failure in the long run, software development teams must build systems of ownership, accountability, and traceability around it. In this post, we'll focus on service ownership. Why is service ownership important? How should teams self-organize to achieve it? Where is the best place to start? Software as a product, not project. Product and engineering leaders at the world's most successful technology companies will agree that an application should be regarded as a product, not a project. Traditional teams who treat software as a project may have one development team responsible for writing some piece of code and another operations team responsible for maintaining that code in production. If you are familiar with Amazon's you build it, you run it mentality, you know that this model is organizationally risky at best and a disastrous barrier to success at worst. Inspired by Amazon CTO Werner Vogels in 2006, engineering teams have since worked towards a world where developers who build a piece of software are accountable for operating it, accountable for responding to late-night outages, fixing bugs, enhancing testing, and assisting with customer support tickets throughout the course of its lifetime. This makes for high-quality code, increased agility, and stronger empathy with users. 13 years later, this model continues to prove successful. The service ownership dream. In the context of microservices, the developer accountability that comes with software as a product is what service ownership is all about. Let's say you are on a DevOps team that runs some combination of the following: a collection of APIs, front-end component libraries, a Grafana and Prometheus stack for monitoring, and a set of Docker images for users to deploy your application. Adopting a microservices architecture means decentralizing everything such that each service is independent and has an explicit boundary from the rest. But what does service ownership in this context actually mean, or not mean? Service ownership means that there is a clear person or group of people who are ultimately held accountable for the success of each service. Successful service ownership does not mean that the owners of a service are or should be the only humans modifying its code. Larger teams typically host over 200 plus services, some of which will inevitably have interdependencies. And it's critical that the knowledge around that service doesn't live in a silo. Service owners are simply responsible for making sure that the rest of the team has access to the information they need to properly modify it. At Cortex, we'd say that if service ownership is done well, the following is true. 1. Every single service is defined, documented, and tracked in a single place. If you are not using a tool like Cortex, this should at the very least be a spreadsheet. 2. There are no orphaned services. Every single service has a distinct owner and an explicit purpose and boundary. 3. The team responsible for a service is also responsible for on-call rotations and support escalations in case of a bug, failure, or incident. 4. Each service has a defined SLO, and owners of that service are held accountable for hitting that target. 5. Information is shared and well understood across teams. Engineering managers, SREs, and developers understand and are committed to this model. 6. GitHub repositories have clear code owners that correspond to the owners of that service, and CI/CD workflows reflect that ownership. 7. Your organization has a culture of empathy and accountability. Team members assume good intent and own their impact. This list might sound intuitive, but it's much easier said than done. If your product covers a large service area, you might be surprised to find a service running in production that hasn't been touched in 5 years. If you are a high-growth startup, you might find that constant role change and pivots in strategy make it hard to define ownership that sticks. It's easy to not invest in the process, but the long-term risks are high. The risk of not investing. Here at Cortex, we've seen teams struggle with 2 primary consequences. 1. Higher frequency incidents. If your services lack ownership, failures become both more common and that much more difficult to both diagnose and address. 2. Unintentional impact on users. If you have an orphaned service that at some point added value to users but is no longer owned or maintained, you may risk an active customer installing that piece of software or leveraging that feature in a way that degrades their experience with your product and goes beyond what you officially support. The risks here might sound obvious to avoid, but what is the best place to start in pushing for ownership? Where to start? Here at Cortex, we work with teams of all sizes to make sense of and manage their microservices architecture. We encourage all organizations to make knowledge less tribal. If you have adopted microservices but haven't quite reached service ownership nirvana, there are some easy places to start. 1. Create a spreadsheet that lists every single GitHub repo in your organization. You might want to track the following columns: repo, description, owners, last updated, keep, yes or no, link to documentation. 2. Make note of all repos that are no longer used or needed, and archive them or set a clear end-of-life date while your team evaluates. 3. Identify one owner, team, or a person for each repo, and make sure they are listed as official code owners. If you are not sure who should be the owner, reach out to recent contributors. 4. Lock that spreadsheet and share it widely. Pin it to the appropriate Slack channel, send an email to your team, etc. 5. Create a dedicated Slack channel for each service, such that the rest of your team knows where to go for questions or issues. You can also integrate tools like PagerDuty to get alerted in case of a failure, or Circle CI for event-based notifications on builds. 6. Write dedicated documentation for each service, whether that be via READMEs, Google Docs, or Notion pages. If a new engineer joins your team, they should be able to quickly identify all services and learn about each of their functions. Make sure to cover things like, what does this service do? What languages and technologies are used? How is it deployed? How is it versioned? What are its availability SLOs? What is the process for new QA changes? Are there documented performance benchmarks? 7. Create a production-ready checklist for new services. What's the process for creating a new service? What criteria needs to be met? 8. Keep track of notable incidents, outages, or failures for each service, and hold the service owners accountable for writing a blame-free postmortem that involves other stakeholders as needed, for example, customer support, product, etc. Anything on this list will go a long way in creating a healthy, agile development team and a reliable product. If these steps are helpful and you find yourself maintaining spreadsheets for more than a few months, consider a tool like Cortex to help you stay organized in an automated way. Spreadsheets are great in the short term, but they require manual upkeep and can quickly become so out of date that they defeat their own purpose of keeping your team informed and accountable. You just listened to How to Drive Ownership in Microservices by Cortex.io. Software as a product, not project. That's one of the microservices characteristics listed in an article on martinfowler.com under an article titled Microservices, a definition of this new architectural term, by James Lewis and Martin Fowler. That article was published back in 2014, when microservices was indeed still new. This characteristic discloses that each microservice should be owned by a team that is responsible for driving its success over its lifetime. Now, as has been pointed in the article, that doesn't mean contributing to that microservice is exclusively done by that team. In order to enable that, I think building small, simple, and granular services that any software engineer in the organization is able to comprehend and contribute or modify the service code easily is essential. Of course, measuring that, we always measure everything that could be measurable, relies on the organization's culture and business demands. Figure out how much time it takes for newcomers or internals who have very limited to no knowledge of that part of the code. And as a general guideline, if it takes more than 2 to 3 days, then it might be too complex. Now, on to the tool of the day. Problem: I can manage all my Kubernetes config in Git, except secrets. Solution: encrypt your secrets into a sealed secret, which is safe to store even to public repository. The sealed secret can be decrypted only by the controller running in the target cluster, and nobody else, not even the original author, is able to obtain the original secret from the sealed secret. You probably guessed what's today's tool. Yes, it's sealed secrets for Kubernetes. Sealed secrets is composed of two parts: a cluster-side controller/operator, a client-side utility called kubectl. The kubectl utility uses asymmetric crypto to encrypt secrets that only the controller can decrypt. These encrypted secrets are encoded in a sealed secret resource, which you can see as a recipe for creating a secret and can be stored in your GitHub repo. And once unsealed, this will produce a plain old secret that will appear in the cluster after a few seconds. And you can use it as you would use any secret that you would have created directly, e.g. reference it from a pod. To learn more, search for sealed secrets on GitHub or check the link in the description of this episode. And that should do it for another episode of Softwareable Bytes. Have a great rest of your day, and I'll see you here again in the next episode.